You know the feeling, right? You ask your AI assistant what seems like a totally simple question. You're hoping for a quick, clear answer, and what you get back is, well, it's not quite right. It feels like it should be easy, but behind the scenes, it's this huge computational maze. So today, let's pull back the curtain and see what's really going on.
So you might ask something exactly like this. It's a perfectly reasonable request, right? You've got a list of car rentals, and you just want the AI to tell you which one has the highest score for cleanliness. Simple. Or is it?
Because this is what the AI actually sees. It doesn't get a nice, neat little spreadsheet. Oh no. It gets a massive, messy wall of structured data. In this case, it's a JSON file, which is just a standard way for computers to talk to each other. Your simple answer is buried deep inside all of those nested brackets and quotation marks.
And that brings us to the heart of the problem. How is an AI supposed to navigate this data maze to pull out the one specific piece of information you asked for? And more importantly, why does it mess up so often?
Well, it turns out this is a fundamental challenge for even the smartest AI models out there. Researchers have a fancy name for it, the tool response processing task. But we can just think of it as the AI's complex reading problem. You know, it's one thing to read a story, but it's a whole different ballgame to read a technical manual written in code.
Now, here's what's really wild and kind of shocking. A new research paper dug into this exact problem and found that even at top-tier model like GPT-4o, its maximum accuracy is only around 77% on these kinds of tasks. That means nearly 1 out of every 4 times even the best AI is getting the answer wrong. That is a huge margin of error. So, to figure out why this was happening, a team of researchers basically built a virtual test lab for large language models. They wanted to systematically break this problem down and figure out which strategies actually work for getting reliable answers.
And their method was incredibly thorough. First, they grabbed a bunch of real-world API data, all that messy stuff we saw earlier, from things like travel, shopping, you name it. Then they came up with different kinds of questions. They ran these tests on 15 different models, from the big household names to smaller ones, and they compared a whole bunch of different prompting strategies to see which one would come out on top. And here's the crucial thing they found. The type of question you ask matters a lot. A simple extractive question, like the one on the left, is just asking the model to find one specific value. But a complex aggregation question on the right, that requires the model to do so much more. It has to find all the values, compare them, and then perform an operation to find the highest one. This is where most models really start to struggle. But the really great thing about this research is that it doesn't just tell us there's a problem. It gives us a playbook for how to fix it. Based on their thousands and thousands of tests, they came up with 4 clear, simple rules for building better, more accurate AI agents. Okay, rule number 1 is the big one, and it's a little counterintuitive. Are you ready for this? Don't ask the AI to read the data and give you an answer. Instead, ask the AI to write a little piece of code that will find the answer for you. And this chart shows you exactly why. For those really complex tasks, if you ask for a direct answer, you're only getting about 53% accuracy. That's barely better than a coin flip. But asking the model to generate some Python code to parse the data, boom, accuracy shoots up to 79%. The takeaway here is crystal clear. The AI is a much, much better programmer than it is a data analyst. All right, rule number 2 is super simple and pretty elegant. If you're sending your AI into a complex jungle of data, give it a map. In the world of APIs, this map is called a schema. It's basically a table of contents for the data file. It tells the AI what all the fields are called and what kind of information to expect in them. And the study found that just including this schema in the prompt can boost performance by up to 12%. That is a huge gain for such a small effort. Rule number 3 is a bit of a warning. It turns out more data is not always better. AI models suffer from a kind of cognitive bias, just like us humans, called lost in the middle. They really struggle to find information when it's buried deep inside a long document. Just look at this chart to see what I mean. As you move from left to right, the amount of data the AI has to sift through gets bigger and bigger. And look at what happens to the lines. For most models, performance goes down. Some of them just plummet. The model literally gets overwhelmed and lost in all that data. And this leads us right into rule number 4. So, what do you do if your data is just too big to fit in one go? Well, the key is this.
If you can't give the AI the whole library, it's still way better to give it a single chapter than to just give it the table of contents. This chart shows it perfectly. Look at the bar on the far left. With all the data, you get about 75% accuracy. Pretty good. Now look at the far right. If you provide no sample data, just that map or schema we talked about, it drops all the way to 60%. But that sweet spot in the middle, providing a condensed sample of the data, keeps the accuracy at a very respectable 68%. Okay, so we've got our rules for success. But what's actually happening under the hood when even these really good models fail? The researchers basically played detective to find the most common ways these things break. And they found 4 main culprits. Sometimes the AI just misreads the structure, like it finds the right kind of data but in the wrong place. Other times it gets tripped up by what's called semantic ambiguity, where you have multiple fields with similar names, like name versus room_name. A lot of the time, it just fails to follow simple formatting instructions. And finally, sometimes the models just write bad code that's buggy and won't even run. So let's put all of this together into a practical guide. The research team managed to synthesize all of these findings into a simple, actionable framework for anyone who's trying to build applications with these models. And this is where it all comes together. The researchers took everything they learned and boiled it down into this, a decision tree that helps you choose the right strategy for your specific problem. It walks you through all the critical questions starting from the left. Can your data actually fit in the context window? Is your question a simple find this one thing kind of task, or is it more complex? If you can answer yes to these checks, then maybe direct answer generation on the right will work just fine. But for pretty much everything else, the safer, more robust, and more reliable path is to have the AI generate code. So getting a straight answer from your AI isn't just about asking a better question. It's really about understanding how the AI thinks and structuring your request to play to its strengths instead of its weaknesses. This research gives us the playbook to do just that. So the only question left is, what are you going to build with it?